Hi, Standard 8 candidates and Class 7 pupils. I welcome you all to our science lesson today. Still, we are on energy. The subtopic is magnetic energy. Magnetic energy is a form of energy passed by magnets. This form of energy causes attraction and repulsion of magnetic materials. Pupils, we have magnetic materials and non-magnetic materials. We are starting with magnetic materials. Magnetic materials, these are materials which are attracted by magnets. All magnetic materials contain iron, or magnetic materials contain iron. Examples of magnetic materials are tin, iron, nickel, steel, cobalt, chromium, and alinico. I repeat, examples of magnetic materials are tin, iron, nickel, steel, cobalt, chromium, and alinico. Non-magnetic materials, these are materials that cannot be attracted by a magnet. Why? Pupils, because they do not contain iron. Examples of non-magnetic materials are copper, silver, plastic, brass, rubber, hair, diamond, zinc, and aluminium. Next is electricity or electrical energy. Pupils, energy produced by moving electrons is called electricity or electrical energy. Uses of electricity are as follows. But before that, we have some sources of electricity are bicycle dynamo, generators, drive cells, and the solar cells or solar panels. Uses of electricity. Pupils, we want to see the uses of electricity. One, electricity is used for cooking, warming, cooling, operating electric appliances, ironing, and refrigeration. Pupils, it is produced when two materials are rubbed together, therefore they get charged. Static electricity can be witnessed when 1. A comb picks small papers after rubbing it on air. An inflated balloon rubbed on the sweater sticks on wall. Nylon cloths produce a crackling sound when removed from the body. The charges of a static electricity behave the same way a magnet does. Pupils, two materials charged by the same material rebel when brought together, but two materials charged by different materials attract each other. Therefore, two uncharged materials have no effect on each other when brought together because they don't have charges. Number two is current electricity. Current electricity, this is a form of electricity that travels through wires. Sources of current electricity include dry cells, car batteries, bicycle dynamo, hydroelectric generators, petrol and diesel driven generators, geothermal generators, wind driven turbines, and then solar energy panels. Pupils, we want to have a look on a dry cell. Dry cell. Dry cells have special chemicals that produce electricity. This electricity is in dry cells is used in torches and radios. A dry cell has two terminals. That is, positive terminal where we have the plus and the negative terminal where we have the minus. Pupils, two or more dry cells connected together make up a pattern. Each dry cell has a total voltage of 1.5 volts. When a dry cell has been used up, it has to be thrown away. Next is the car battery. The car battery pupils. A car battery, this is a special kind of battery that supplies large amounts of electricity. A car battery is used to run the electrical parts of a car, such as lights, heating, and starters. When we talk about starters, when the vehicle is being started, heating, when it is giving a warning sound or a calling sound, and then the lighting of headlamps as well as indicators. A car battery pupils, once used up, it can be recharged. A car battery can also be used in a house to operate radios, televisions, and lights. So once the car battery is used up, you don't throw it away because it's rechargeable. It can be recharged so that it can be reused again and again. Next, pupils, we move to bicycle dynamo. Pupils, a bicycle dynamo is a small electric generator attached to the hind wheel of a bicycle. It is mainly used to light the bicycle lamp at night. It has a knob that rotates when the bicycle is moving to produce electricity. If you look properly, we have parts of the bicycle. We have the mudguard, the one which The mud guard prevents the bicycle from spraying the mud to the user. Then we have a connecting wire. If you look properly, we have a wire which is connected to the bicycle dynamo. Then it is attached to the bicycle wheel. So as the bicycle wheel moves, the knob on the bicycle dynamo rotates, thus producing electricity. Next, we move to hydroelectric generator. Pupils, hydro means water. Hydroelectric generators, these are special generators run by flowing water. They are usually fitted below a dam or a large waterfall with the purpose of trapping electricity. The flowing water is used to turn turbines that in turn produces electricity that is used for various purposes. Pupils, dams that are specially made to produce electricity are known as hydroelectric dams. Hydroelectric dams, these are dams that are specifically made to produce electricity. Large-scale source of electricity comes from hydroelectric dams. If you look on the picture, that is an example of hydroelectric generator, whereby the turbines are heat by water, they rotate, and then they produce electricity. Next is petrol or diesel-driven generators. If you look at the generator, some generators use petrol, while others use diesel. Those ones who use diesel, we call them diesel-driven generators. Those which use petrol, we call them petrol-driven generators. Examples: petrol or diesel-driven generators. These are generators that use diesel or petrol to turn their turbines. They are mostly used during times of power failure. Petrol or diesel emit gases that pollute the environment when they burn. Next, we have wind-driven turbines. Pupils, wind-driven turbines. These are turbines rotated by moving air. Moving air is what referred to as wind. What is wind? Wind is moving air. To produce electricity, a special structure known as windmill is constructed. The kinetic power of wind makes the plates or turbines to rotate at a high speed, producing electricity. The picture you are seeing is windmill turbine. Next, solar energy. Solar energy is energy from the sun. Solar means related to the sun. Solar panels are usually used to harness electricity or electrical energy from the sun. Pupils, the panels have light-sensitive cells that trap sunlight and convert it into electrical energy. Always the solar panel is fitted on the roof so that nobody is tampering with the cells, so that it is able to trap the solar energy from the sun. Next, we have what we call geothermal. Geo means earth. Pupils, geothermal is a source of current electricity. It uses steam from underground to rotate the turbines. The word geo means earth, while thermal means heat. Therefore, pupils, heat from underground boils water to change into steam. This steam is collected using pipes and directed towards the turbine. If you look properly, we have cables, we have the generator, also we have turbines and the steam. If you look, steam is collected from the ground through the pipes. They hit the turbine rotates and the changing, producing electricity, then it is generated through wires where it is going to be used. Next, circuits. One is circuit. If there are many, we say circuits. The birth, or that's the root, followed by electricity, is known as electric circuit. This electrical path is made up of a source of electricity such as a dry cells, we have a pallet, we have connecting wires, we have switch. When these parts are connected well, that is source of electricity, that's a dry cell, a pallet, connecting wires, and the switch is close to the pallet lights. Let us have a look on our setup. We have two dry cells, we have connecting wire, we have a pallet, and we have a switch. Pupils, the moment the switch is switched on, if it touches the other wire, the pallet will lit. Pupils, the circuit is only complete when the switch is closed. Like now it is open. The moment it is open. The moment it is closed, when the switch is open, the circuit is considered to be incomplete. So the moment the other wire touches the other wire, we say it is complete and the pallet will live. We move to good and bad conductors of electricity. Pupils, good conductors of heat and bad conductors of heat. We start with good conductors of heat. Pupils, materials that allow electricity to pass through them easily are known as good conductors of electricity. All metals are good conductors of electricity. Some materials only allow small amount of electricity to pass through them and are known as poor conductors of electricity. Pupils, examples of nonmetals which are good conductors of electricity include mineral water, acids, and graphite. Bad conductors of heat or electricity, these are the materials which do not allow electricity to pass through them completely. Are said to be bad conductors of electricity. Most of them are used as insulators, at contact switches, and the covering of wires to avoid electric shocks and the short circuits. Examples of good conductors of electricity include plastic, rubbers, wood, ordinary papers, and the cloth. We move to Electrical appliances at home. Electrical appliances at home. An electrical appliance is a device that uses an electric current to function. Examples of electrical appliances used at home and their uses have been tabulated below. Let us look on the appliance and its use. Number one, we have iron box. An iron box is used for ironing or pressing clothes to remove creases. Appliance number two is radio. A radio gives us information and entertainment. Three, we have television. Television pupils give us information and entertainment. The difference between a radio and the television is that television you can be able to see the pictures as well as the sound, whereby in radios you hear only the sound. Fourth is electric cooker for cooking, refrigerator for food preservation to avoid making food misuse, electric kettle used for heating or boiling water. Lastly, we have immersion heater for heating or boiling water. Safety measures when handling electricity. Pupils, the following are safety measures that is used that should be observed while handling electricity. One, do not touch electric switches with wet hands. Why? This may cause electric shock. Two, do not insert objects in electric shock sockets to avoid wires or electric shock. Three, avoid overloading sockets. This may cause overheating, which can result in a fire. Four, do not repair electrical appliances when the power is on. Five, do not touch naked or bare wires. Six, unplug electrical appliances when not in use. Lastly, use the appliances according to the manufacturer's instructions. Lightning. Lightning is a strong form of static electricity. It occurs when clouds are charged either positively or negatively due to friction between them and the air. When two charged clouds meet, probably positively charged cloud and a negatively charged cloud, a spark of light is produced. This is known as lightning. The thickened air expands and vibrates vigorously, producing sound. This sound is called thunder. Lightning and the thunder takes place almost simultaneously, but we see the lightning first before hearing the thunder because light travels faster than sound. Safety precautions against lightning. The moment we are done with this, we come to the end of our lesson. Safety precautions against lightning. Avoid walking in open fields when it is raining. Lightning always strikes the tallest object. Wear rubber-soled shoes when it is raining because rubber is a poor conductor of electricity. Avoid sheltering under trees or leaning on walls when it is raining. Fit lighting arresters or conductors of building to protect them against lightning. Pupils, if you look at the picture on the screen, if you look at the picture on the screen, whereby we have a tall building, the lightning arrester are made of thick copper wire. Avoid switching, swimming, and the other water sports such as surfing when it is raining. Avoiding carrying or holding, standing, or walking near metallic objects when it is raining. Pupils, up to that point, we come to the end of our science lesson. Inshallah, next time we are going to look on sound energy. Until that fine moment, I wish you a good day. Assalamu alaikum warahmatullahi